Hey guys, so we are going to add on to the exponent rules that we were talking about on our bell work last week. Today's focus is all about multiplication. So anything that has to do with multiplication properties of exponents is what we're going to do. Anytime you need to pause this video to write something down or catch up, feel free to do so. I've only got 15 minutes, so I'm going to kind of fly. All right, let's start with the acronym that I taught you guys last week for exponents. So MADSIM. If you don't remember what that stands for, find your note card and write it down because it's going to be really useful. So anything with the multiplication properties. So we're actually going to focus on two. When multiplying, we add the exponents. And then also when we have that exponent to the exponent, the power to power rule, we're going to multiply. So I've given you quite a few examples. I'm not going to do all of them in this video because I don't have time. I'm just going to cover a few, but I will have all of them done on OneNote. So if you're looking like, yep, I definitely need some more examples, then go to OneNote and get those, okay? So our first problem, the quantity of 3x squared y to the fifth times 9x cubed y to the negative 10th. So again, what did I just say? Times. So I'm going to multiply. So when I multiply, I add the exponents. So first start by multiplying our numbers. So 3 times 9 gives us 27. And now we go to our exponents. So I've got an x squared and an x cubed, same base of x. So I keep my x. And when multiplying, we add the exponents. So 2 plus 3, 5. And then y to the fifth and y to the negative 10th. So again, same base of y, but when I add a negative 5 and a negative 10, that's going to give me a negative 5. So hopefully you guys remember, this is simplified. However, when we are writing it, no negative exponents allowed. Hopefully you saw that. So I'm going to go ahead and set up my fraction. So everything that stays, I'm going to keep it. So 27 is fine. Remember, your coefficient is allowed to be negative. That's totally fine. It's the exponents that can't. So 27 is good. X to the fifth is good. To get rid of those negative exponents, we take the reciprocal. So drop it to the denominator, and it is positive. Don't forget to make it positive when you drop it. And that's it. So our next one we have is the quantity 9x to the negative fourth, y to the eighth, and then we're going to cube all of that. So this one, the first one was a product of powers, so we had exponents involved, but we were multiplying. So this next set is power of a power, or power to a power. Always, always, always come back to your order of operations. Is there anything that we can do inside the parentheses? 9, x to the negative fourth, y to the eighth. So there's nothing to do. So then we move to our exponents. So we are going to cube everything that is in the parentheses. So first we start off with 9 cubed. So 9 times 9 times 9, that is 729. And then we have negative fourth cubed. So remember, exponent to an exponent is growing even faster. So instead of adding, we're going to multiply. So negative 4 times 3, negative 12. And then y to the 8 times 3, 24. All right. All good? No. No, no, no. Always look at those exponents. So since we have that negative exponent, we need to flip. So 729 is all good. Y to the 24th, beautiful. But that negative exponent, go ahead and drop that to the denominator. Don't forget to make it positive once you do. No, I'm not going to always torture you with negative exponents, just in the beginning. Okay, so the next one I want to do, you see this? This is a multiplication problem, but it's also got exponents. Both of these are to exponents, so we have a lot to do here. So this is a combination of both of our rules. So let's see. 2a cubed to the fourth, and then a cubed. And I'm going to write myself that multiplication just to make sure I, remember. So order of operations, nothing to do inside our parentheses, so we go to exponents. So what is 2 to the fourth? 2 times 2 is 4, times 2 is 8, times 2 is 16. And then again, we have exponents to exponents, so we're going really fast. So 3 times 4 gives me a to the 12th. And then I've got to do this one as well. So a cubed cubed, so 3 groups of 3 gives us a to the 9th. And now that we just have a regular multiplication, MADSIM tells us to add. So the 16, that's my only coefficient. And then I look at my a's and just add them up. 12 plus 9, a to the 21st. Sweet. Okay, I have other examples for you. Like I said, once you're done, if you definitely want some more examples, I'll have all of those done for you on OneNote. Okay, now let's talk about scientific notation, because I have a feeling for some of you it has been a while. So we can actually use our product rules when multiplying scientific notation. So an automobile company sold 2.3 million new cars in a year. If the average price per car was $21,000, how much money did the company make that year? And they want us to use scientific notation. So they sold 2.3 million. So I need to write that. I don't know how to write that in scientific notation. So I need to write it in standard first and then go to scientific. So 2.3 million. So 2,300,000. So if we go to write it in scientific notation, hopefully you guys remember, you move that decimal place until you just have one number in the one spot. And then whatever's behind it, you can just keep. So my decimal is now back here. So I move 1, 2, 3, 4, 5, 6 times. So 2.3 times 10 to the, we move that decimal place, 6 times. This might seem silly, but with how much money they're going to make, you're going to understand why we do this. All right, so to figure out how much did they make, well, how many did they sell times the price. So we now need to multiply that by the price. So the average price they told us was $21,000. So let's put that in scientific notation. So we then have 2.1 times 10 to the 1, 2, 3, 4th. So when I go to multiply in scientific notation, this is where our rules come in. First, we just multiply our numbers, 2.3 times 2.1. And then we have our tens. So 10 to the 6th times 10 to the 4th. So 2.3 times 2.1 gives me 4.83. And then times 10 to the, well, when multiplying and they have like bases, MADSIM tells us multiplying, we add the exponent. So 10 to the 10th. So all it wants is the answer in scientific notation. You're good to go because it didn't move the decimal outside of, like, we only have a number in the ones place. If it would have been like 48.3, we would have had to move the decimal and add one to our exponent. If you're curious to see how much that actually is, that's your answer. But I'm kind of curious, how much is that? Like, that seems like a lot of zeros. So 4.83, and we're going to move our decimal 10 places. 8, 9, 10. Fill in my commas, so hundreds, thousands, millions. 48,300,000,000. That's how much that company made in their car sales. That's pretty awesome. Okay, so when you're doing scientific notation, remember, once you convert both to scientific notation, multiply your numbers, then multiply your base 10s, and put it all together. Okay, so of course we need a little bit of real world area. So we are talking about a Rubik's Cube. So a puzzle cube is solved by having all 9 squares on each face. Okay, I need to envision this. No, you don't have to draw this if you don't want to. Okay, so I have 9 squares on each face to be the same color. If a face of each of the squares is xy centimeters, so each one of these is xy, I'm not doing that many times, then what is the volume of the puzzle? All right, well first, how do we find volume of a cube? Length times width times height. Okay, so what is the length of the cube? Xy, xy, xy. So how many xy's is that? 3. So 3xy for the length, and then the width and the height, everything's going to be the same because we got a 3D figure, and it's a cube. So if I've got 3 of them, can I just cube it? So you could do this 2 different ways. You could do 3xy times 3xy times 3xy, or I could also do 3xy cubed because I'm multiplying it by itself, and then we just simplify. So 3 cubed gives me 27, x cubed, y cubed. So that's how we find the volume of our Rubik's Cube. I don't know. It's kind of a stretch, but you know, they like their real